Chris Clark. A lot of you probably know him. He's an engineer at the Whatcom Conservation District. He holds an Ag Engineering PE Professional Engineer's license. He's with the CD since 2000, writing dairy nutrient management plans. And he also does designing and helping producers implement best practices. So a lot of you probably work with him on something related to a technology or a plan on your farm. And Chris is going to be talking about new technologies and things of interest. And one of the surveys that you have relates to that. So if you haven't filled that out, as Chris talks, you can fill that out and let him know what other things you'd like to know about.
Turn on the mic.
So one of the first things on that paper was there any questions on the nutrient management? Talked about so far? No one's going to ask some questions all day, so I'm not the best speaker in the world, so I'd rather have questions. The montage of pictures up here, projects that we've worked on or proposed in the future to work on, and we would like to get information or questions about things like the technologies such as global positioning and record keeping on the yield mapping pieces. I do work with the cost share programs, and we do have some funding sources to develop some of those technologies. A lot of the things behind me are newer projects. The lagoon liners, something that is required by waste storage facilities now, whether it's a clay liner or a synthetic liner. We put those in. The clay liner has been the most economical in our area. We do have clay, local clay sources, and other areas of the state, they don't have that clay resource, so they do use synthetic liners. Manure storage is a big issue because of the design standards, and then things like the recent press's attention from leaking lagoons. And the design standard for a 3 million gallon lagoon is that if it was completely full at 9 foot of water, head pressure on that lagoon, it would leak 1,000 gallons per day. That's the design criteria for an NRCS permeability rates of 10 to the minus 7. You do the calculation, and that's the number, the magic calculated number. Last year I did a study where I put irrigation water filled up 4 lagoons, measured them, and they didn't leak anywhere near that number on 3 of the lagoons that were even built to old standards without any liner whatsoever, and one that was built to today's standard, and one that was a few years older. One of the ponds did leak a little bit worse than that 10 to the minus 7, but it had just been built right on top of the soil. They put walls around it and use it as a lagoon. The issues with that number is, again, we're talking about nitrate leaching in the groundwater. Manure doesn't have nitrates in it when it starts off, so that lagoon leaking into the ground or releasing that 1,000 gallons per day, the nitrate number below that lagoon, in studies by ecology before my time in the 90s, showed that there was lower or relatively low nitrates just coming from that lagoon. The question, again, on the conversion of that nitrate, when it's anaerobic underneath the lagoon, it's not going to convert to that nitrate, the ammonia that's coming out of it. So that's kind of a false thing that they're putting out there. When you hear about some of that information, it's challenging. We'll get back to the subject of new technology. The big pieces with the new lagoon standard, and then cost share program, we are evaluating lagoons, trying to make sure that they were built to the standard, or they're still being used to the standard that they were built. If you've modified them since they were built and it's not been brought up to the standard at the time you did the construction, there could be some issues with that lagoon being certified by NRCS. Within the cost share realm, they will ask you or provide some cost share to help you fix that, or ask you to bring it up to today's standard. And that is a big cost. The the main requirement on waste storage ponds is that 1 foot freeboard going into the full period. You're not supposed to be in that top foot, and that's to keep the water from leaching or being sucked into that top foot, into the clay, and compromising the top of the lagoon. So please be aware of that this time of year. Some of the newer practices that we have put in place, the mortality facilities where people are composting their cows on slab areas. We've put some roofs on those kind of facilities to help minimize the water leaching onto them. One producer used some woven wire with plastic on it to keep the animals out, to keep the birds out, and coyotes and stuff like that. The irrigation pieces that you see here, the big guns, we are still cautionary on big guns, flow meters, pipelines. Pipeline requirements on the tri-action valve, you see one there. There's irrigation pods for smaller pasture systems. Drainage issues, drainage improvement issues, keeping those drainage cleaned off. The lay flat hose. There's some systems that make record keeping with the global positioning stuff. We have not cautioned on. No one's come forward on that piece. And again, if you're interested in that, the EQIP program, the federal EQIP program, heard a little bit about that today. In our office, the NRCS is actually going to vacate our office, and so we don't know where they're going to be actually situated at in the next month or so. That EQIP program goes through them. Their telephone's still going to be the same ones we have now. However, it's going to put some limits on how we work together. So if you are in that program and you are expecting us to be working together as we have in the past, that may not be the case. So please be aware of that. And I do recommend you talk to NRCS. Joy was here. I don't see her right this second. She hiding. One of the things that technology pieces that we do have with the use of the internet is Google Earth. And Google Earth is a free program with aerial photos on it. You can actually add pieces to it that makes your life easier if you're interested in it. And it's a documentation piece again for those records that you're looking at or being required to take. Google Earth is the aerial photos. They come in annually. I'm zooming into Abbotsford Airport. There's a historical photo or timeline there that allows you to see which year the photo was. So as those photos change colors, those are different years. So if you're looking at older photos, you can. In some areas, they are more available than others. The ability to add links to this, you can draw your field map on there by hand. There's a tool that allows you to build fields. And change your color, do whatever you want to do on that. Within our farm planning though, we do have, most people have their farm plans already developed by the Conservation District. And actually Andrew can put this your farm plan map directly onto a file that you can open up in Google Earth directly, so it'll help you get to your location. You can add links, so that manure tool Nicole was talking about earlier, you can go directly to something like that. You can also, again, your farm plan map is what most people have a farm plan map. Again, Andrew will put those fields into the Google Earth form. And that will take you to a map system that allows you to, over the internet, connect back and change your field. If you want to add a field, delete a field, change the field size from your farm plan map, that's your farm plan map. The pieces that I have added on to mine, and again, you can link some of these pieces up. You can go in and with the farm map that Andrew creates, it gives you the acres that your farm plan is based on. And so you can get that information also by creating some of the links. We have worked with Google Forms to do new application records, keeping pieces. That will help with that as well. Internet is slow.
So, Chris, I have a question. So, through Google Earth, are you able just to click on a field map, you know, which would be just a file, and directly enter through Google Documents or Drive nutrient applications,
Yes.
which would be just saved via Excel spreadsheet or something like that?
Through Google Forms is what I'm hoping will come up here. But, the map that you have for a farm plan, if you have Google Earth already on your computer and you ask Andrew to do the KML, they'll send you that file.
Yep.
That file, if you click on that on your email, it'll load that right onto Google Earth.
So then you're just setting links on each field to a Google form, which is basically like your response for your application records?
Yes, within that individual field,
Yeah.
you add your link to it,
Yeah.
and that gets you back to that Google form.
Google form where you can enter whatever your application or however you design that form.
Yep.
Okay.
And then you can do your application, and that sends it right back to
Yep.
the spreadsheet.
So that would be the link. However you set that up, it would link to
Yep.
whatever
And you can-
gallons or method or.
That's right. And you can send this response back to your consultant. You
Right.
can send it to your own computer. You can do this on your phone. You can do it without a map. You can have it already loaded on your phone, so all you're doing is looking at field number 2
Right.
and do it that way without the map process. The idea is try to get the records into place and have some of the calculations done with ongoing nutrient numbers so that you know how much is left in the budget for that crop year. On the individual new technologies, one of the big ones is the digesters. There are lots of questions on how digesters perform. We have questions on nutrient availability, the regulations that surround them when we're putting in. The digesters that are usually been proposed or installed have included substrates to come into those to make a profit for that practice. Those substrates add another layer of regulation to them that requires additional documentation and updating of farm plans, and it makes it a little more challenging for the operator, but it allows that fertilizer to be put on other fields where we are trying to keep track of that within, helping the producer keep track of that within the regulatory realm is a challenge. And they can be substantial high numbers in those nutrients, especially nitrogen, from some of the substrates that come in from the processing, or food processing industry. On application equipment, there are some of the manure applicators that are out there that we're not using currently. That we don't have the same systems as what they have in Europe, where a lot of these are being developed around tank systems with a lot smaller gallons per acre than what we deal with our storage facilities and the amount of rain that we have. We have a challenge trying to get the amounts out into the field. The question on lagoon covers or separators or concentrating the nutrients down so we can have a smaller amount go on the field and have an agronomic application, and then have that applicator actually dialed into the GPS and record keeping. It's all being done at different levels, except when we get to these high volume applicators, where I have not found anybody that will say that they're using the systems that are being promoted or being expected to come into the future of you recording every one of your applications with an exact nitrogen amount, with the mineralization of what comes out of your soil, organic matter, and your irrigation. There's no bundle of that information out there to work with at this time. So that's what the future's holding in the regulation if it comes to pass, and I would hope that the dairy industry will pick that up and push some direction of where they want that to go, because it's going to be an issue just keeping the amount of records in that regulation. It is above what we're talking about right now. Anybody have any questions?
What about phosphorus removal? Where's that currently at?
Separators by themselves remove solids. And as the separators have advanced, depending on what you're using the solids for, if you're using it for bedding and you're squeezing out more of the liquid, you're actually squeezing out more of the phosphorus, because the liquid does hold the majority of the phosphorus. As they go to centrifuges or different pieces where they're getting more and more of those fines out, there's going to be a number that goes along with them. Again, the data that they talk about having a number of 90% removal of solids still leaves more than 10% of the phosphorus in the liquid. It is not, you have to be careful what they're talking about. It is solid removal versus phosphorus removal, and the total phosphorus isn't all just in the solids. There's dissolved phosphorus, the orthophosphorus they're talking about the plant needs. It is already broken down into those small soluble forms that will pass through that separator. The future holds on that. Hopefully, the precipitation of it with things like lime that they've tried with other facilities, there are ways to get to that. They're just very costly. Some of those numbers, they've done some of the studies with the digester pieces where they've actually removed nitrogen, potassium, and phosphorus to get it down to clean water. And you see those numbers and you wonder, by the time you're done investing in all that infrastructure, the land base that you needed it would have been cheaper to buy that land base than all that infrastructure. But there are those systems that people are looking for.